Hello, calculus fans. Okay, so we're going to do an example of a problem where we need to make a substitution before doing integration by parts. So what we'll do is we'll evaluate the integral from 0 to 2 of x cubed e to the minus x squared dx. Alright, so in this case we're going to make a substitution. So w is equal to minus x squared, and I'm choosing that because that's the inside function. E to something, that something is often an inside function. So dw is negative 2x dx. Really, we don't see a negative 2x dx, so we'll just divide by negative 2 to get the x dx. Now this is a substitution, so we have to change limits. U of 0 is equal to 0. U of 2 is equal to negative 4. Remember, we're plugging things into the substitution here. Alright, so let's see what we got. Integral from 0 to 2 of x cubed e to the minus x squared dx. Now break things up a little bit just so that we can see that this is the part that we can change into a dw rather easily. If you go back to what we had computed, that turns into something. And so now when we transform everything, this is what we're going to get. Negative w e to the w times negative 1/2 dw. So how did this first piece come in? Well, remember that w is equal to negative x squared, so x squared is negative w. And notice that we've changed the limits of integration. Alright, so if we clean up, the minus signs cancel out, the 1/2 gets pulled out in front. Now I'd like to integrate by parts. So u is equal to w, and dv is equal to e to the w dw. That's using the detail rule. So we have the exponential and we have the algebraic, the e and the a. So the e, the exponential, should be chosen as the dw. It's closest to d in the detail rule. du is equal to dw, and v is equal to e to the w. That's just because if you anti-differentiate e to the w, you're just going to get e to the w. Alright, so let's put all this together. uv minus the integral of v du. And the 1/2 gets pulled out in front. Then when we integrate the e to the w, we'll just get e to the w. And so that's how we have the 1/2 e to the w here. And you keep in mind that this minus 1/2 came along for the ride. Then if we plug everything in, we'll get something that looks like this. And so this is our final answer. You might notice that we used a w for our substitution. That's because we needed to make a integration by parts change later on, and so we kind of wanted to use the u and the v for that. So we used a w instead for the substitution. Okay, that's all for now.